Hello, everybody. Welcome to this session, AI Power Digital Twins from Strategy to Implementation. My name is Leo Salcé. I'm an architect and technologist, been in consulting for close to 20 years, supporting a lot of companies from all sizes around the world, from design through construction and into asset management and the whole project lifecycle. I've presented at a lot of different events and conferences worldwide, and continue to speak and present on topics related to innovation and technology for the AEC and how that provides benefits to the industry. The topic of today is digital twins and the combination of AI to actually go from a concept to actually practical use and devising the benefits of an implementation. So, without further ado, due to the short duration of this recording, let's start with the implementation steps. I always recommend piloting a project, regardless whatever initiative you have. Is always starts with the problem, and I'll actually outline it in a better breakdown. But it's about planning. What is the project? What is the initiative? What kind of technology supports that process? And then how do you define success? And then, of course, is when it comes to digital twins, is how do you blend all this information so that what is the intent, whether it's a design related initiative or construction or into asset management and operations, which I'll spend a little bit more time on that side on the FMOM, which is the asset management component. But in terms of a breakdown, this gives you a good snapshot of something that can be copy-pasted in a different sort of structure. But the idea is to define the objectives and what is it that you're trying to solve? What is the business objective, and of course how these use cases that you define can impact those. Anything from cost reduction to more efficiency, productivity that actually impacts any other processes that are performed during design, through construction and operations. Then, of course, is how do you define data collection strategies? How do you leverage the models? To what state of the models? How do you leverage AI in that process? And then how do you actually put together a process where you can benefit from the whole defining the entire process? So it starts with the drivers. It means it's not just a problem, but what is it that you're trying to achieve? Whether it is you want to impact customer or guest experience, or you want to reduce costs, etc. So this is just a snapshot of a typical process where you identify what is it that you're trying to solve. Quickly identifying problems, quickly solving those problems, and that reduces potential lawsuits or risks. It actually just saves a lot of time, which translates to saving a lot of cost. On an annual basis, depends on repetition of instances and so on. So this just gives you an idea on just having access to accurate information anytime, anywhere. It's a good driver for a lot of owners and people that are in the operations and maintenance side. Then depends on the organization. If it's a hospital versus an airport versus any other type of facility, you identify use cases that are very relevant to that, because every organization has its own sort of motto or concepts that they care about. If it's a hospital, for example, they care about not just costs. Operational costs is in the top three, but then cost per patient per care, patient care and patient safety. How do you address all of that into how does the digital twin and then how does the AI actually means anything? So you identify use cases, optimizing, work order performance, being able to prevent problems before they happen, be able to, preserve knowledge instead of having tribal knowledge, visual inventory, integration with different systems for CMMS and other facilities type of processes. But then within that, you have different groups. So this is just an example of, within, let's say, facilities department or facilities management, you have different groups. And then within those different groups, you have different entities that actually have a say in the budget. So it's not like, implementing a digital twin is going to save everybody time and cost and all these different things. Identify granularly who's benefiting from this particular process. The way you do it now versus the way you're presenting and proposing. And then what do you need for existing legacy projects versus the ones that are in the pipeline, that new buildings and new projects that are coming up? So then that way from an owner standpoint, you know what to ask, and then you know what you want your consultants to deliver. So having standards and having sort of guidelines for what is going to be beneficial for you to receive at the end, so you can use this information for, you know, whether it's leveraging AI for insights and making better decisions, or just using dashboards to kind of streamline the decision-making process and access to information. So it means, you know, you can ask for the world, and but it's better to be prepared in terms of what's important, what's relevant, and then it goes down to, you don't need everything. You need just relevant information. So depending on the entity and the organization, it starts with the data dictionary or information asset records, and everybody calls it differently. But the idea is that all this information from that is collected during, you know, a BIM process, then it actually leverages all this data so that people can make better decisions and then can access that information later on. Of course, it ties into the geometry and the model. So it means that you have the data, you have the model, and then to what level of detail and what extent that need to be. And then what other complementary, supplemental information like cut sheets, warranty information, operation manuals, etc. What is that, you know, how is that accessed and how is that combined and collected and digested into one source? And of course, once you identify all these different processes, which again, you can expand it and definitely spend more time talking about it, you identify what are the technologies that are going to support that process. So then you make the decision of whether there's something in the marketplace commercially available. So you look at just three major technologies. One is the BIM authoring tools, the CMMS, which are the ones that are used for operations and maintenance. If we're talking about the life cycle. Then you have the data integrators. The data integrators is the one that connects whatever BIM platform to those systems, and then or other systems, and then how do you visualize all that information? And then the AI side, which is another level of information sort of management. So a good approach when you evaluate commercial versus custom development is, does a tool in the market do what you want, you know, like, you know, 100%, or at least close to everything that you need? So my advice is always have that business requirement list, identifying what kind of functionality, and I always say tier level information, which is based on the level of sophistication of the user and the country or the, you know, the organization. Then you kind of identify what might be too overkill or what might be really realistic. Because again, the idea is that you can select technology, but then is it going to be accessible in a third world country, or, you know, somewhere where there's no internet, or somewhere where, you know, nobody even has an iPad. So it's about identifying what technology exists that is going to be suitable for the country, for the culture, for the cost. And then does it make sense to devise something that is actually proprietary and maintain it, you know, for the lifetime of the technology? So that's where this is a snapshot of, you can collaborate with any developer, either in-house or, you know, outsource, and then develop a strategy where you can develop, you know, create a solution that actually fits the exact criteria. Now, that said, there's a lot of challenges that need to be defined, and this is usually outlined under standards on FM guidelines or BIM for design, construction, and operations if you have the entire kind of life cycle. But it's about what kind of information, how is that information collected, and then when, who is responsible, and where does that go, and what kind of technology. So this is sort of the questions and the cycle that allows you to actually avoid these data management issues, which is you have wrong processes, you have no requirements, you lack responsibility or accountability, so or you're using the wrong tools, and then that impacts, you know, schedule. So in the end, what I just said for the last 9 minutes, this is critical, because if you don't have any of that, you can choose technology and really cool, you know, processes and tools, but they're not going to mean anything because it's not going to be applied, it's not going to be adopted, and it's not going to be implemented properly. So it starts with data collection, which again, I've mentioned this before in other presentations, so bear with me if you've seen some of these graphics. There's all this technology that is evolving, that is really fast evolving. So from just 3D scanning, technologies that are doing laser triangulations, light scanning, contact-based 3D scanning, and there's all these different systems that now can expedite doing existing condition capture of a building. Then I'm gonna get into more sort of holistic, where you can do things even faster. Maybe at a more sort of city level, which I'll show in a second. But the idea is that you can use AI and tools that are kind of emerging and are evolving and maturing to the extent that they can accelerate the process of digitizing and collecting data. That means I'm talking from the point of view of geometry. Then the data collection from the point of view of data, there's different ways that you can go about it, but usually that's populated in the model, and then or from extracted from drawings. But then, to accelerate things even at a higher point, like, digitize asset conditions, even for, planning and zoning, and even like the urban design. So you can use existing technologies like drones, but then some of them are evolving into having AI, computer vision, where now instead of creating a mesh and creating this photogrammetry 3D model, you actually can identify segments and then have conditions and criteria where it's identifying what buildings are going to be, let's say, old based on KPIs, or they're going to be demolished based on certain volume analysis, or what properties are unauthorized, what is a relic. I mean, this is just an example of an algorithm that actually breaks down a single mesh into segments based on specific criteria. And there's processes that allow you to go from that mesh that is photogrammetry point cloud into something like Rhino or Civil 3D that it used to take a lot of time. This is even more accelerated now with other processes like nerves and instant nerves and other type of similar neuroradiance fields type of technology. This is by NVIDIA. So the idea is that you no longer need to capture, a lot of footage from videos, but can snapshots here and there, and then create a 3D model that allows you to have enough information to actually produce a potential 3D geometry-based scan that can have enough information for you to, integrate it with your, digital twin platform, and then have the data collected and the IoT, et cetera, and so on. So once you have the data, the idea is how do you blend it into making real-time decisions? So there's so many things you can capture from, if you think about it from a modular standpoint, energy, equipment, security, safety, occupancy, etc. And then all of those, my recommendation is to do like Fitbit, which is a very popular device here in the US. You collect information and you display that information very easily. So there's a lot of companies that are coming out, and some sensor entities that have a very easy way to plug and play and start collecting information about equipment, about energy usage, about lighting, about occupancy, space usage, etc. And in the past, it used to be that you have very limited, systems that were very expensive and they're very closed ecosystems. Today, you have a lot more options, and you have a lot more open source options as well. But technologies are plug and play, that you can just like attach it to a piece of equipment and then start collecting information. And most of them, they already have a dashboard that has some predictive capabilities for failure and measuring specific sort of physics. This is an example of just a open source for visualizing sort of information from IoT. But in terms of use cases, you can go large scale to granular, which is what I show about buildings. So you can collect data about a city, about an area, in terms of a lot, for example, and then start performing planning information integration, comparative analysis, project site analysis, and visualization of planning conditions. And then you can integrate all this multi-level information, transportation, energy, underground space. I mean, there's so much stuff that can help you kind of make better decisions. And in the end, think about it like a Google search engine for buildings, where you can visualize and query any information from a database, from any database, and plan development, capital restrictions, time limit, building height, landscape requirements, and so on. So from an owner standpoint in development, this is very, very useful. And the idea is that you can use this, again, even for, we've seen it, in practice for like leasing management, where you're like identifying, if you have a large owner with a lot of properties, filter by parameter and say what is rented out in this region or this zone, and then emphasizing what areas, and then be able to see and provide recommendations on a commercial, real estate, or residential, and so on. The idea is you combine all this data and then you access it and make it easy to digest. This is just a simple example of combining data from sources that include logistics for shipping, includes the whole GIS, the whole region for civil and landscape, but then also a plethora of other systems that provide data and they just allow you to query and inform the user. So in the end, is modular. That's the way I always recommend. So you can talk about lighting management, you can talk about power distribution management, you can talk about safety and security, and within those you have all these different sort of criteria. That's why it's very hard to find a solution that does exactly what you want. You always have to spend some level of customization. So in this case, is information about energy tracking or lighting, levels, or information about, specific things related to, the meters, like safety information where you're seeing ventilation problems. And the whole idea is, and I'm talking about it from the point of view of operations and asset management, but even on the design side, this is very helpful. I've seen a lot of people using, this information from IoT devices and AI to see predictive patterns for like occupancy. You can do a post-occupancy evaluation to ensure that the design met the intent on our architectural side. You can do workplace optimization for evaluating, sustainable design criteria like lighting levels, humidity, comfort level, and so on. And then more specific, we've been involved in projects that are very meticulous on what they want to see. Like maybe they want to see rentable space, they want to see CO2 level, they want to see, simulated sort of conditions that are projected in real time, and then have some kind of simulation component to it. But then, the model has all these potential use cases, depends on what intent you have and on what phase of the project, whether it's design, whether it's construction, or whether it's operations and management. So this is just an example of using that model for prediction or for about simulation of fire exit, and then just being able to see how many people can flow at a certain time on a certain time frame. So there's so many different AI subsets. What everybody talks about is more like the generative AI, which is generate a picture, generate a rendering. That's fine, but there's so much data, and AI has a huge implication on how do you process that data, that there's a lot of frameworks, and I've talked about this in other sessions, but just to give you more use cases, the monitoring and predictive is a huge part. So on the asset management side, going back to that, you can, have anomaly detection, full diagnostics, and then time to failure forecasts, which I've seen a lot of companies like airports, organizations like airports, that they want to go from capital planning, budget planning to, they want to go from operational CapEx to, from OpEx to CapEx, I'm sorry. So what it means is when you are budgeting for operations, there's a lot of reactive, higher cost than when you plan it during capital planning budget. So with this, you can kind of forecast, if there's a piece of equipment, if there's anything in the building or in the whole set of properties that can potentially have recommendations. And this is where AI excels, is the ability to use that data in a meaningful way. So it actually detects patterns, and then it tells you, what can potentially happen, what does it recommend, and then what are the next steps. So I talked about chatbots, which are fantastic assistants that can give you so much insight about information that is happening, combining all this data. But then I'm just showing you here an example. Even during the design phase, there's things that you can do open source, like machine learning for predicting room assignment, predicted door assignment, and then just based on training your own data sets. And then, you can have a faster kind of optimized automated process to, populate information or generate information within the model and so on. Lastly, the potential for something that is now active or is being sort of in development for a long time is the multimodal language models, which what it means is combining all this data from not just images, text, from audio, from video, from heat maps, from all these different conditions. And this is, where they were advertising a year ago, is the ability to use, let's say, computer vision to identify and provide context to what's happening. So this has been done by very expensive, more expensive technology like Watson from IBM, that it was used heavily on like oil and gas for prediction of, conditions of inspections for like, oil and gas refinery piping and so on. What I want to show you is the potential things that we've been prototyping and testing on our side is you can do segmentations about an image. You can take a photo. That photo, you can generate, extract the information, identify what's there. And then the idea is that you can easily then, combine all what I just said here about you have the image. It's not just render another image based on texture, but tell me what do you see, or based on what I tell them to generate and describe and identify. And then from that, connect to a database. And that database will tell me, I'm actually, this is commissioned, this is installed, this wasn't on the last, image. So it's a way to accelerate the way that you do inspections. Just another thought about using AI for just generative AI. It's another like a inspection check. So that said, there's a huge potential for combining again digital twins, all the different sort of processes in between. But it starts with identifying the problem that you want to solve. So in the end, it's just identifying what you want to solve and then dividing the process from there. So it's a lot of information in a very short amount of time, but hopefully that provides more insight. So thank you very much, and I appreciate your time.